We are looking at trigonometric identities and equations. On this, we are going to be applying our trigonometric ratios in solving equations. Okay, so on this, we are going back to our unit circle. We have this right angle triangle. Here is cos theta, here is sin theta, and here is 1. So we have tan theta is equals to sin theta. I would like us to just refer to our trigonometry where we have sine as opposite divided by hypotenuse. Then we have cos theta as adjacent divided by hypotenuse. So looking for tan theta, we are saying that is sine. Tan theta gives us what? Opposite divided by adjacent. Simply, if I do sine theta divided by cos theta, it's going to give me opposite over hypotenuse divided by adjacent over hypotenuse. So we have opposite over hypotenuse times hypotenuse over adjacent. So cancelling out, I'm going to have opposite over adjacent. And that means it's simply tan theta. So tan theta is equal to 1 sin theta divided by cos theta. So this is how this is gotten. So using the same principle here, we have sin squared theta. This is our sin squared theta plus cos squared theta. We give us what? 1. Where we have h squared in our Pythagoras theorem, we have h squared equals to 4 squared plus adjacent squared. So we have our hypotenuse square, which is 1, and we have our opposite square, sin theta and cos theta. So we have that as 1 is equals to what? Cos square theta plus what? Sin square theta. So this is Pythagoras giving us this equation. So you have to bear this in mind. Tan theta is equals to 1 sin theta divided by cos theta, and sin square theta plus cos square theta will give us what? 1. So we are working with that in order to solve your equations on trigonometry. So we have tan theta is what? Sin theta divided by cos theta, which is also sin square theta plus cos square theta is 1. Then we have tan 2 theta, just double of it. We want 2 sin theta or sin 2 theta divided by cos 2 theta. We have sin square 0.5 plus this, which is 1. So we have these trigonometric identities to work with. So I would like us to take an example applying this trigonometric identity. We have to prove that 1 minus tan theta sin theta plus theta is equals to what? Cos square theta. Using this, we derive tan theta is what? Sin theta over cos theta. Then we have sin square theta plus cos square theta is equals to 1. So we apply that to prove this theorem. I'll have 1 minus tan theta. Already we know tan theta is what? Sin theta divided by cos theta. So multiply by sin theta here. Also multiply by cos theta. We are proving that. So simply I'll just strike out my cos theta. I'm left with 1 minus sin theta multiplied by sin theta will give 1 sin square theta. Okay, and we know that 1 is what? Sin square theta. We are replacing 1 with sin square theta plus cos square theta minus sin square theta. So sin square theta minus sin square theta is 0. So we are left with what? Cos square theta. We are proving that this is equal to what? Cos square theta. I hope you got that concept. So let's take further practice on that. Prove that tan theta plus 1 over tan theta is equal to 1 over sin theta cos theta. We already know that tan theta is sin theta divided by cos theta. plus 1 over sine theta. I'm replacing tan theta with sine theta divided by cos theta. So we have sine theta over cos theta. We give what? Flip up, we have cos theta over sine theta. Okay? Adding this equation, I'll look for the LCM of cos theta and sine theta gives us what? Cos theta sine theta or sine theta cos theta. So divide by this, what do we have? Cos theta sine theta divided by cos theta will give us sine theta. So sine theta multiplied sine theta gives me sine squared theta plus cos theta sine theta divided by sine theta gives us cos theta. Cos theta divided and multiplied cos theta gives cos squared theta. So we have this, and we already know that sine squared theta plus cos squared theta is equals to 1. So we have 1 over sine theta cos theta. So we've proven that. We have further proving to do. So prove that tan x plus x into root 1 minus cos x squared is equals to 1. Like we know earlier, tan x is what? Sine x divided by cos x multiplied by cos x. So cos x cancels out, and that upper value we have sine x. Then we have for root 1 minus cos square x. We have 1 minus cos square x. If you remember, we have sine square theta or sine square x plus cos square x is equals to 1. So if you want to make a sine, subject to the formula, we have sine square x will be what? 1 minus cos square x. So we are replacing this with 1 minus, on this becomes sine square x, which is 1 minus cos square x. So 1 minus cos square x gives us what? Sine square x. So sine square x will give us sine x for this value down here. So simply we are saying sine x divided by sine x will give us what? 1. So we have proven that theory. So it is easy. Try as much as you can on proving trigonometric identity. Now we move further to solving trigonometric equations. The first question is solve sine theta is equals to half in the interval of 0 to 360 degrees. Then we have sine theta is equals to half. What I have, I'll now have my theta in what? Sine inverse of what? 1 over 2. From our trigonometric equations, we have sine inverse of 1 over 2 as what? 30 degrees. And referring back to our quadrants, we know that this sign of angles is positive. So theta can be 30 degrees, or my theta can be 180 minus 30 degrees, which is what? 150 degrees. So the value of theta in that is what? 30 degrees or 150 degrees. So this is how to solve trigonometric equation. I'll move to the next question. The same 2 cos theta equals to what? Root 3. So simply what I do here, I divide by 2 and divide by 2. That means I have my cos theta as what? Root 3 over 2. So our theta will be what? Cos inverse of root 3 divided by 2, which will give us, so this gives what? 13 degrees. Or we'll say cos is what? Is positive on my first quadrant. That can simply give me 360 degrees minus 30 degrees, which is what? 330 degrees. So the value of theta is 130 degrees on 330 degrees for that. So let's move to the third question. We have 5 tan theta is equal to what? 10 in the interval of minus 180 degrees to 180. So I'll divide both sides by 5 here. So that means tan theta will give us what? 2. Then we have theta as what? Tan inverse of 2. So we have it as 63.4 degrees as our theta, or the value of theta could be 3.4 minus 180 degrees. So we have 63.4 minus 180, which gives us minus 116.6 degrees. So that is the value for theta. Please try as more examples and more questions. You can lay your hand on trigonometry equation. So we'll move further to more. So we'll be using factorization methods to solve for the following equations. So using quadratic, this is a quadratic equation. So what we'll do here, we are going to be factorizing this. The first question is sine squared theta minus 3 sine theta plus 2 equals to 0. So factorizing this, the normal factorization, I have 2 sine squared theta. So looking for the factors of 2 sine squared theta, I will have 1 sine squared theta and 2 sine squared theta. So these two will give me the factors applying to this. So I'll have sine squared theta, minus anyone can go ahead and have minus 1 sine squared theta minus 2 sine squared theta. I'm replacing it 3 by that plus 2 equals to what? 0. So you group there. What is the common factor there? I have sine squared theta in that. So sine squared theta divided by sine squared theta gives 1. And sine squared theta here, we have sine squared theta divided by sine 1 sine squared theta on this. Sorry, this is sine theta. Sorry, this is not sine squared theta. This is sine theta. So whatever is common here is sine theta. Sorry for that error. So I have sine theta here. Here gives me sine theta minus 1. Okay. Then the second one, the common is 2. So same thing I have here, I should have here. So I have sine theta minus 1 also. So the equation is given us sine theta minus 2 and sine theta minus 1. So that means we are seeing sine theta minus 2 equals to 0. So sine theta is equals to 0 plus 2, which is 2. Or sine theta minus 1 is equals to 0. So sine theta is equals to 0 plus 1. Sine theta is equals to 1. So this is how to factorize the quadratic equation. So we'll move to the next question on that. So the second question is 2 cos squared theta minus cos theta minus 1 equals to 0. So same factorization, factorizing this. So that is 2, 1 multiplied 2 cos squared theta. This is what we have. So the factors of 2 cos squared theta is also 1 cos squared theta and 2 cos squared theta. So I'm going to substitute this value. Please remove the square because I want to multiply this. So the square is not necessary because 1 cos theta multiplied 2 cos theta gives us 2 cos squared theta. So applying that, I have 2 cos squared theta minus, we are looking for minus 1. So it can be plus 1 cos theta minus 2 cos theta minus 1 equals to 0. So grouping these guys, common is cos theta on that into 2. So dividing there, I have 2 cos theta plus 1. Also minus what is common here is 1. So I have 2 cos theta plus 1 equals to 0. So bringing this equation, I have 2 cos theta plus 1 equals to 0. 2 cos theta equals to minus 1. So that gives cos theta as well minus 1 over 2. Or we have cos theta minus 1 equals 0. Cos theta is 0 plus 1 with cos theta is 1. So we have our theta value as well minus 5 or 1. So we have solved that equation using factorization. So let's move further to this. This shows that 4 sin square x minus 3 cos square x equals to 2 can be written as 7 sin square x equals to 5. So bringing that question down, I have 4 sin square x minus 3 cos square x equals to 2. Okay, so we have 4 sin squared x. We did earlier that cos square x plus sin square x equals to what? 1. So for cos square x is going to be what? 1 minus sin squared x. So we are substituting 1 minus sin square x for cos square x. So I'll have minus 3 into 1 minus sin squared x equals to 2. So opening the bracket, I have 4 sin square x minus 3 plus 3 sin square x equals to what? 2. So I'm going to collect like terms, which I will have 4 sin square x plus 3 sin square x equals to what? 2 plus 3. So 4 sin square plus 3 sin square will give us 7 sin square x, which is equals to 5. So we have shown that that equation is equal to this. So the big aspect of this is to solve for x using the value of 0 to x and also to 5 to solve this equation and give our answer to decimal basis. So solving, we continue from this equation, which is 7 sin squared x equals to what? 5. So we divide by what? 7. We say sin squared x is what? 5 by 7. So that means we have our x will be, so we have our x as 1. So our x can be pi minus 1.01 times 22 over 7. I have that as 3.14. 2 minus 1.01. So 3.142 minus 1.01 gives 2.1. Our answer is 2 places. We can also have the value for x. We're getting for pi minus 1.01. They can also be pi plus 1.01. So we can have 3.142 plus 1.01. So that will give us 4.1 also. Or we can have it as 2 pi minus 1.01. So the option 2 pi will be 6.282 minus 1.1. So subtract that on your calculator. So that gives us 5.3 decimal point. So values for x we have 2.1, 4.1, 5.3. We are using 4.1 and 5.3 respectively. So this is the value we got for x. Thanks for staying with us in our class. I think we have covered most of the basics in trigonometric identities and equation. Please try as much question as you can. Thanks for watching.